So a polynomial is something which is going to have a sum of a bunch of monomial terms. So here comes another example of a polynomial. I want to kind of take apart, let me put two different examples up on the board, and we'll kind of look at how are they similar and how are they different. So here's a couple of polynomials. 4x to the fifth minus 12x squared plus 1. So there's an example. And then also negative 6x squared minus 3x plus 5.
These are polynomials.
Yeah, so each of these is a polynomial. And if you don't believe me, how do we know? How do we know that each of these is a polynomial?
More than one term.
It has more than one term, and each of the terms is what?
A mononomial.
Each of the terms is a monomial. So I realize I should probably put that definition up here to make sure that it's on the board. So a polynomial is an expression all of whose terms are monomials. Maybe I should say each of whose terms is a monomial. Each of whose terms is a monomial. And so these two are examples of polynomials. How are these two examples similar? What's the same about these two polynomials? They both have three terms. That's definitely important. Anything else that's similar about these two? Okay. They both have a whole number. In fact, all the coefficients are whole numbers in both of these examples. So whole number coefficients, that's the same. What else? Jordan?
They have two variables each.
Okay, so whole number coefficients, two variable terms. Anything else? One of the things that jumps out at me is that the variable is the same in both, right? They both have x as the variable inside of them. So there's a lot of similarities between these two polynomials. What's an important difference? Over here, exponent of 5 and an exponent of 2 versus, okay, so that's true. Although I might come back and say, well, what about this plain x here, this in the second expression? What's the exponent on that x really? Yeah. So don't forget, if you have a plain old single variable by itself, it does have an exponent even if we don't write it. It has an exponent of 1. So if I put that 1 there, now that takes away that difference. So what else could we say that distinguishes these two polynomials from one another? Yeah. Negative number where? At the beginning. Okay, so over here, this negative 6 that's out in the front here is a negative coefficient versus over here, the coefficient here is positive. Okay, what else?
I'll say different exponents in different places.
Okay. So these two polynomials have different exponents in different places, right? If we look at the exponents on the polynomial on the left, we've got an exponent of 5, and we also have an exponent of 2. And then we also have, in this term, there's no exponent at all, so I'm going to call that an exponent of 0. How about this polynomial? What are its exponents? 2 and then 0, because there's no exponent in that third term. Okay, great. So these polynomials are very similar. They have 3 terms. They all have whole number coefficients. One of the terms in each is a constant, while the other 2 have variables. Both of them use the same variable. But where they differ is that they have different exponents. They use different exponents. And also that the signs of some of the coefficients are not the same, right? Specifically, the sign of this first term that's written in each one is negative on the polynomial on the right, positive on the polynomial on the left. So here's the only other really important definition when it comes to polynomials. Why might I want to zero in on this coefficient? The coefficient that is in front of the x to the fifth on this first polynomial is in front of the x to the second on the second polynomial. Why is that term somehow more important than the other terms? Any ideas? So I might be inclined to consider that these first terms here, the 4x to the fifth and the minus 6x squared, I might be inclined to consider those as to be more important than the others because, on the one hand, each of them has the highest exponent in its respective polynomial. So that's the first thing that we'll observe here, is that the degree, so this is the definition, the degree of a polynomial is the highest exponent in a polynomial. So in our first example, the degree of that polynomial is 5. What's the degree of the polynomial over here on the right? Yeah. Again, the highest exponent. There are some very good reasons, some of which we'll hope to see this semester, but you may wait for a later semester to appreciate what's the reason for focusing in on the highest degree as opposed to any of the other terms in a polynomial. One of the reasons is, let's suppose x is a very, very, very large number. X is 1 billion or something like that. If x is 1 billion and I square it, I'm going to get, gosh, 1 billion billion, which is 1 with 18 zeros after it. So gigantic number. Much, much, much larger than even 1 billion itself, and certainly a whole lot larger than 5. So the term that has the highest exponent in it kind of wears the pants in the polynomial, right? It calls the shots that when x gets very, very large, only that term matters, and the others are so much smaller in comparison that they may as well be irrelevant. Okay? So we have good reasons for caring about the degree of a polynomial, because that is the term that's going to control most of the behavior of this expression. So that's something to know. The definition of the degree of a polynomial is that it's the highest exponent that's present in one of the monomial terms. And to go along with that, the coefficient of that highest exponent also gets a name. It's called the leading coefficient. So this is, again, just terminology. But when we use this terminology, that's what we're talking about. So the leading coefficient is just the one which is attached to the term that has the highest exponent. So the leading coefficient in the first polynomial here is 4. The leading coefficient in the polynomial on the right here is -6. So that's all the definitions that we're going to need in order to start working with polynomials and understanding kind of how they're put together. We know what a polynomial is. It's an expression in which each term is a monomial. And the degree of a polynomial is just the highest exponent that we find on any of the monomial terms that make up that polynomial. Attached to that highest power of x or whatever the variable is, that coefficient gets called the leading coefficient.